Hi, welcome back to Moose in Chemistry. This is Electron Configuration of Krypton, KR lesson. So when we look at the periodic table, we notice that Krypton has an atomic number of 36. This is the 36th element of the periodic table. And its atomic mass number is going to be 84. Okay, so Krypton has 36 protons, and since it's electrically neutral, it would have 36 electrons. What about the neutron count? Well, you go AMU minus protons equals neutrons, right? So you go 84 minus 36 would give me 48 neutrons, right? So that's doing pretty snarly right now. So we'll write a 48. All right, let's go ahead and erase that. Give us some more space. And let's go ahead and look at our electron configuration. Oh, before we do that, remember that S can hold 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons in its subshell. And also remember that we use the off-ball principle where you fill in the lower shells first before you fill in the upper shells, and we're going to use it using the diagonal rule. So here we go. 1s2, 2s2, 2p6, and 3s2, 3p6, and 4s2, 3d10 and 4p6. So it'd be 3d10 and 4p6. And we add that all together, we get 36 electrons. Well, let's look at orbital notation next. Orbital notation uses Hund's rule. Hund's rule basically states that for every suborbit, you have to put an up arrow in that suborbit first, fill those all in, and then do this down arrow of that suborbit. So let's go ahead and do that. So you go up arrow, down arrow, up arrow, down arrow. 2px, 2py, 2pz. Now watch this. Down, down, down. And that's Hund's rule right there. Yes. 4, 5, and 6. 4s simply up and down. 2, 3, 4, 5, 6, 7, 8, 9, and 10. Pretty snarly, huh? I'm going to go 1, 2, 3, 4, 5, and 6. Well, that's it for orbital notation. What about noble gas notation? Guess what? Krypton is a noble gas, so it's its own notation, Kr. And that's what you're going to write, and that's all you're going to write. The quantum numbers, N, L, M, and S. Well, Krypton's in the 4th period, so the principal quantum number is 4. It's located in the P block, so its angular momentum number is going to be 1. The magnetic number, of course, will be minus 101, minus 10, and then 1, because it's on the very end right here. Right? So you put a 1 right there. This last arrow is going down, so that's going to be 1/2 negative. So that's going to give us the value right there, 1/2 negative. Well, that's it. You guys be snarly, and we'll see you back here at Moose in Chemistry.